This is what we call a radio over fiber using atomic gas. So what we've got here is a radio signal coming out of this antenna, and the atoms are inside the glass cell here. And when I turn on a radio frequency signal here, atoms sense that, and a light beam passing through the atoms, this glass cell, picks up that radio frequency signal, which is then coupled into an optical fiber, as you see here, and that signal is then retrieved on a photodetector, which goes into the speaker. This is a new technology where the wireless data is directly written into optical data, which can then be transferred using optical fiber. So this basically links two sort of very important technologies of modern days. One is the wireless data transmission, and another is fiber optic communication. So this is an interface device in some sense, which is a prototype, but it's a new device, and it leads to a very, very simple setup where you basically just have a piece of glass cell containing the atoms, and atoms are so sensitive to those radio frequency field that just that glass cell and a light beam is enough to transfer radio frequency signal to the optical domain and to the optical fiber network. Communication is, of course, telecommunication is, of course, one obvious application of this. For unconventional communication, such as used in military devices, it's quite important to get rid of external electromagnetic interference. And this technology is purely optical. There is no electronic component in here, and that's why it's really hard to interrupt externally and interfere with. On top of that, we also believe that this can pick up physiological signals from human body, and that could be quite useful in medical devices that are sensitive to metals, because this glass cell this whole technology is metal free. So for instance, you can't put metals inside MRI machines. So this may be a technology that this can be useful for.